not just within the energy needs of a particular cell. So thyroid hormones set our basal rate of metabolism. Insulin and glucagon control what happens to glucose in and out of the liver. There's fat cells, as we've talked about, been found to release hormones that control our appetite. So,
It was leptin.
yeah. And so these hormones are often controlling the flux in and out of storage depots, energy storage depots. Where do we have them? Let's look at where we bank energy. So this chart, or this table, shows available energy in kilocalories. Okay, so remember you can read these as nutritional calories. 1 kcal is the same as a nutritional calorie. So where do we have it in the form of sugars, like either free glucose or tied up as glycogen? In different tissues, well, there's marginal amounts here and there. There's a little bit in the liver, 400 calories worth. I'll speak in nutritional terms. 400 nutritional calories of glycogen in the liver, 1,200 calories in muscle, where both of these are places where you have glycogen. Little bits in other places, but not much. If you look at fats in the form of neutral storage lipids, the triacylglycerols, a little bit in the liver, a little bit in muscle, about 135,000 calories worth in fat tissue for the typical adult. And proteins, a little bit here and there, but mostly that's in the muscle. This is technically right, but when you think about protein as an energy reserve, you got to be thinking worst case scenario, right? It's not like, for these guys, we make special carbohydrate called glycogen, and we store it for later use. We make these triacylglycerols not for any functional purpose like a memory lipid, just for energy storage. We tuck them away in special cells. We don't have the equivalent for protein. We don't have cells that are just storing extra protein that's not functional. You do see that in nature, like in seeds in particular. Our whole thing of agriculture, and rice and wheat and so on, that these are little pods of storage protein that aren't serving any functional role. They're just there to be broken down later for energy and building blocks. But we don't have that in our body, except under fasting or starvation. That's kind of the energy reserve of lasprozoin. But it is an energy reserve.